Hi, I'm Dave the RPA guy, and in this Blue Prism tutorial, we'll be looking at the text functions in Blue Prism. This is part 9 of our function series, and it's the last one of the function series. We're going to be doing string manipulation. I'm so excited. As we go through these text functions, take a look at how I use them and consider whether or not it's the most effective or efficient way to do it. If you have a better way, I want to hear about it in the comments. So let's go ahead and zoom in on our window and get started on these. Let's begin by looking at the functions that we'll be talking about today. First, let's go into a calculation stage. We're going down to the text functions group. We've got character, concatenate, ends with, in string, left, length, lower, mid, new line, replace, right, starts with trim, trim end, trim start, and upper. Those are scattered throughout these stages in our process flow. What I'm attempting to do is make it clear how to use each function while at the same time showing how you can use it in tandem with other functions. Let's start by talking about the character function. In this calculation stage, you see this is what the character function looks like. CHR, and in parentheses takes a number input, and specifically it takes a number input between 0 and 255. Let me show you what I mean. Let's go into the help file, type ASCII, list topics. We've got ASCII codes here. This says American Standard Code for Information Interchange. Okay, so there's a bunch of codes that mean different characters that are, as I said, some on the keyboard and some that are not on the keyboard. Talking about things like open and close parentheses, plus sign. This list actually goes only up to 127, but we're going to pull all the characters between 1 and 255. What I have here is that whenever this calculation stage is called, it will first take whatever is in this text data item called example. It will take a character code. It will put that on the end of the text. The first time it's called, it will obviously be getting nothing and combining it with the first character code, and then put it back into the text item you see right here. It says store result in example. We're going to do that over and over again by using a loop. Whenever the process flow starts at the start stage, it will hit this anchor and keep going downward till it gets to this decision point where it says loop character question mark. Is the character number, which starts at 0 and gets incremented up each time we loop, less than the characters to get. So I've named this characters to get as effectively our loop limit. And once we reach 255, is 255 less than 255? No. And so it will go on the no path and continue on our process flow. But until that condition is met, each time we add to character number by doing this stage here, simply taking the character number and it adds 1 to that and then puts whatever the resulting number is back into the same character number data item, and you got yourself an incrementer. So our next calculation in this loop is the one that we mentioned already. It's going to take whatever's already in example and concatenate that with our character function. Fair warning, you won't be able to read the characters because these are not screen readable characters that are at the beginning of the ASCII codes, 1, 2, 3, 4, 5. Probably after 50 or so, it'll start being human readable characters. So I'm going to step a couple times. So as I'm clicking, you can see that the character number data item right here will be incrementing, and as it reaches this stage, that number will get used to retrieve the character code that we're at the time. You can look in that example data item, you see that it's not really readable. So what I'm going to do is go ahead and play for a minute here to show you the rest of the characters will come out of it. So once we got to this point, it started getting characters like exclamation point and quotation mark and number sign. And then you see it got the full alphabet in uppercase letters, full alphabet in lowercase letters, the bunch of other characters. Our next function is length. We will be calling this a number of times throughout this process flow because as we do this string manipulation throughout, we want to see how many characters are still in our text at that point, and we can determine by how much the text has changed. So let's look at what that function actually is. It says len is how you call the length function, and then provide it an input, and that'll have a number of characters in it. The output you will get from this is a number, which we're putting into num of chars, so number of characters, which is going to be right here. So you can watch this change each time len or length function is called. Let's see an example output from calling that length function. 255 is what it's calculated from this text item, and that's expected because we called the character function 255 times. Next, let's look at starts with and ends with. These are very similar functions. and we can see here that the way starts with is formatted is literally the words starts with, and the input we'll take is our data, which is going to be example in this case, the character or characters that we are looking for at the beginning of that text item. Let me also jump over to ends with and show you that this is formatted exactly the same. We have ends with, and then in parentheses we have the two inputs that are separated by the commas. We're giving it our data that we're looking inside of, and then the second part is the data that we are looking for. So in our starts with, we're looking to see if character code 1 is the first character and if character 255 is the last character. I'm going to step twice, show you that it comes out to true on both counts, and that proves to us that even though we can't read the character here, that is in fact there. Our next function to talk about is new line and concatenate. Concatenate is the ampersand symbol, and this simply takes some text from before it, combines it with some text after it. The other thing is the new line function. What this is effectively is doing is using our character function, except in this case what new line is doing for us, it is getting both the line feed character and the carriage return character, but it takes both of them and puts it into your text, and that tells Windows that we want a new line. And then the other thing I'm doing is I'm adding in some spaces at the beginning along with a few words so we can see the text changes, but we are going to want to trim these white spaces out from the beginning and the end using our next couple of functions. Let's step, and you can see that text data item itself changed. You can see it added some spaces here and it added some spaces at the end. Let's use our length function to see how many characters we have. 286 characters now. Our next three functions, trim start, trim end, and trim, all do the same thing, but just have different scopes. Trim start trims white spaces from the beginning of a text item. Trim end trims white spaces from the end of a text item. And trim does the job that both of these do, which is to trim from the start and the end. I'm going to click step on this trim start. Let's do our length function to verify that it changed. Okay, so we removed 4 characters from this text. We'll do trim end now. Do our length function. Now we have 279 characters, so total we have removed 7 characters. We had 4 white spaces at the beginning and 3 white spaces at the end. I say that because now we have this calculation stage that we want to use. Add some spaces back in. Let's use our length function to verify. Now we're back up to 286 characters. The structure of the trim function is just trim, and then in parentheses you have your data item that you're passing in. Let's step and see. We have 279 characters just like we did after we ran both of these by removing those leading spaces and trailing spaces. Our next few functions we are going to use all in the same multi-calculation stage. We have a number of expressions in a row from top to bottom in a multi-calculation stage. It may appear to you that whenever you run it, that everything happens at the same time. It instead runs the first expression, gets the result, runs the second expression, gets the result, and so on all the way down till it's done. So you saw a whole bunch happen at once. Let's first talk about what my goal was with doing these expressions. An A and a Z will pop up, but we don't know what characters will come between them. Now we do know, however, it will always be alphabetic characters. Our use case here is whenever our text comes in, we need to transform part of it to go from being capital letters to lowercase letters. Maybe some of them are lowercase letters and others are capital letters. So as you saw before I ran this multi-calculation stage, one of these groups was lowercase and the other group was capitals. And so we want this to be all lowercase, and we will actually finish that by using this replace function at the bottom. To prepare for that using that replace function is we want to get all of our A to Z groups all in capital letters first. Let's go through this row by row. In the first row we are using the in-string function. This in-string function takes for the first argument as whatever text we are trying to look in. The second input is going to be the text that we're looking for. This will be a number output, and that will tell us where the letter A is in this text. And recognize that we're searching for a lowercase a here, and you see an uppercase A here. That's because some of our functions down here manipulated the text. So in this case, there was a lowercase a right here. We got a position output of 112. So at the 112th character in this text data item was the letter A. And then we want to find out where the end of our group is that we're looking for. So we're looking for Z. Our output from that in-string function is Z position 137. So we know that 112 to 137 is our first group at least, and we want to find out what the length of that group is, because as I said, it could have any number of characters in between it, but they have to be alphabetic. We're going to subtract A position from Z position will be our A to Z length. Now you'll notice I have a -1 here, and that's because it's actually subtracting the position of this A from the position of this Z. We're going to move backwards to this @ symbol and then find out how many characters it is to get to Z. 26. So in this case, that's what it will be, but it's dynamic enough that even if there were more characters in between here, this would still work. The next row, the mid function, takes 3 inputs. The first one is our text to search in. The second one is going to be a number, which is going to be the position from the left side of the text that we will start taking text from. And then the third input, how many characters do you want to take? That's why we did our calculation up here to find out the length of our A to Z group, because now we can say, all right, mid function, I want you to look into this whole body of text. I want you to start where I know that A is at, and then I want you to go for as long as the A to Z length is, get all those characters and store it into a text data item called AZText1, which you can see is what happened over here. And I should mention while we're at it here, notice the AZ length did come out to 26, so we do have the right number of characters. So in A to Z text1, we have the lowercase letters A, B, C, D, all the way out to Z. Our next row is using the left function. And what this is doing is the same thing as mid, except in this case, it's only going to take 2 inputs because we know that the place we are starting from is going to be the far left side of whatever text item we give it. Okay, so we have example here. So we're taking the same text data item again, but we're going to start from the left side, go out to wherever A is at, -1 because we don't want it to actually take A, and we're going to put it into left text from this @ symbol and back. Should all get stored into left text. So let's go ahead and take a look. Looks like it worked. The beginning, our unreadable characters, all the way up. Let's go ahead and stop for just a second. I confused myself about which of these 2 A to Z groups was originally lowercase, and I've been pointing to the first group. So in all those times in the past minute or two when I pointed to this first group, I probably meant the second group. So now let's pick back up where we left off, where we were talking about this left function, where we are trying to get text from the left side of this entire body of text, because what we want to do is save that text for a period of time so we can stick it back in along with our now uppercase letters as well. Where I said that it should take from the @ symbol and back. In our case, it should actually take from this. It looks like a quote mark or apostrophe or something like that, and back, because the second group was originally lowercase. So if we look into left text, it looks like that's what it did. Can't quite see everything here, but if we open up this text item, it should contain everything before this second group to include the first group. So we've got that in left text. We're going to hold on to that and use it later on whenever we want to build our whole text body back together. The next thing we're going for is to find out what is after our A to Z group. We need to find out what the right length is, and we can take all of the text that is after our right side. So we have number of characters, which is at this point should represent how many characters are in this body of text. And then we're subtracting the Z position, which is the location of the end of our text. And then we want to take everything after that all the way to the end. So we've got our right length now, and we can take the right function and accomplish that purpose now, because what we have is the right length. The length of the whole right side of the text that we want to take. Use the right function to say, look inside of this body of text, and now that I know the length of the entire right section, I want you to use that as how many characters you go starting from the right side, and then go backwards that many characters, take all of that and store it into an item called right text. And at this point, now we have left text and right text and A to Z text 1. So we could take the left text, concatenate that with AZ text 1, concatenate that with right text, and we should have our original body of text. Before we do that, we need to do a little bit of work on the middle piece that we have gotten, which is the A to Z text 1. Let's do the upper function on it, upper, and then inside of it just takes one argument or one input, and that is A to Z text 1, which you can see so far right now what we have is the lowercase A to Z group, And what we want is an output into AZ text 2. Look over to the right side, and you'll see A to Z text 2 is now the exact same text, but in this case, it is uppercase letters. And the final thing we want to do, as I said, our whole goal is to maintain the integrity of this body of text while at the same time converting our A to Z groups to uppercase. So we want to concatenate everything back together. What we saved into left text, we want to put first, and then we'll use the ampersand or the concatenate symbol along with AZ text 2, which is the result of doing an uppercase on our A to Z text. And then we'll use the concatenate or ampersand symbol again with right text. You remember we got from doing the right function or concatenating all that back together, sticking it back into our example data item. We can see that what we got out of it was the same thing we had originally. It starts with the beginning, ends with the end, but what we've changed is that this used to be lowercase and now it's uppercase. Now let's look at another way that you could manipulate something in a similar way, but this is using our third method of doing string manipulation, and that is to put your expressions into the same calculation stage without using multi-calculation. We want to replace in this text anywhere that we find an A to Z group where it starts with a capital letter A, ends with a capital letter Z, uppercase. We want to replace that now with all of that being lowercase. The replace function takes 3 inputs. You can see the 3 different inputs because I've selected the second input. The first one is going to be the body of text that we are looking in order to replace something. And the second input, what is the text that we are trying to replace? In this case, we are looking inside of it, and what this string of characters is doing is picking out specifically any group that begins with A and ends with Z. And then the only thing we want to do in this is change that same group. So if you'll notice mid, example, in string, example, A, it's down here as well. So we're doing the lower function on that exact same text. It all matches. The output we'll get here is that the replace function will take whatever this is and puts it into wherever this is. Click step anywhere that a capital letter A and a capital letter Z, everything in between it turned all that to lowercase and it did it for both of them. I hope that I haven't thoroughly confused you. What my goal was is to show you how to use these functions and to show you almost a reasonable time to do this. It's important to practice the string manipulation. It doesn't mean that when you practice it, your example has to make a whole lot of sense. The important thing is that you can use logic and reasoning skills to determine the order of steps to do something like this and get the output that was intended. In my opinion, this is a very logical way to accomplish the set of steps that we were doing. If you had a different set of business logic, you might do it differently. 2 things I want to mention before we close up this video. First thing is that I did mislabel this turn A to Z to uppercase multi-calculation. I originally had it saying lowercase, but in fact we turned to uppercase, then we used replace to turn to lowercase. So when I did that, it only changed one A to Z group. I just want to point out that if you had multiple A to Z groups, or you expected there to be multiple, you would have to put in a loop to call this stage more than one time. Eventually you'd find there's no more A to Z groups to convert, and then you can move on to your next set of actions. But I just want to point out that this wasn't designed to handle more than one group at a time. The other thing I want to mention is there's actually a fourth way. I mentioned 3 methods for handling this, so, using calculation stages, multi-calculation stage, using one calculation stage with a complicated expression side of it. But there is a fourth way, using regular expressions. You can take this same scenario where we were just trying to look for an A to Z group. We knew what the beginning of it looks like and what the end of it looks like, and we wanted to perform some sort of conversion on that. Regular expressions are fantastic for that, especially in the situation where, as I just mentioned, if you needed to loop through it multiple times, you might have a bunch of different groups you needed to change. A regular expression is literally for that purpose, but there are no regular expression functions here in our inbuilt functions, so that's why we didn't talk about it today. In this Blue Prism tutorial, which was part 9 of our function series, we talked about the text functions that are inbuilt in Blue Prism. We are now done with the functions groups, so in our next video, we can move on to the visual business objects, and there are quite a few of those, and then we can move on to start building out applications and making process automations.